fine. Go on. It'll come to me.
Okay. So our last technical subject is called. Okay, now I lost it too.
Contagious.
It go yeah. Now it'll just spread round and round. Um, Color temperature and white balance. And so, have any of you fiddled around with the white balance settings on your cameras?
Yes.
Any, yeah.
Yeah.
What were your results?
Um, well, it depends for what. When I shoot, like for example, nighttime, I like using incandescent, or I can't even pronounce it right. But
Okay.
I like, yeah, I like using that color balance. And then I mean, even if I was to use like sunlight option, in Lightroom you always have the option of adding blue, or if your picture is too blue, you could always add, yeah, like orange or yellow to make it, to
Yeah.
balance it out. So
So
it's always good. Like you don't have to beat yourself up if it doesn't look how you want it to, because you could always edit it.
very true. Especially, do you shoot in RAW? Do you make RAW images or J?
I just shoot in fine.
Okay,
I have
JPEG.
yeah, I have my camera set on fine.
Hmm. So, what we're talking about is something called color temperature, and it's a way of describing, of quantifying colors. So, when we let's say I have this kind of pinkish reddish piece of tissue paper, and if I go outside in the sunlight, it looks like red tissue paper. If I'm inside under what's called incandescent light, those, the Edison style light bulbs, it looks like red tissue paper. If I'm under fluorescent light, still looks like red tissue paper. In shade, under cloud cover. And that's because our brains, even though I've gone under these different types of light, our brain, my brain, compensates for the changes in the types of light. Um, Film and technically digital sensors cannot automatically compensate for the changes in the types of light. And so color film, for example, for those of you who've actually used film, color film, most of it is designed to be used outside in daylight. And when you don't use it under daylight, your images will have a color cast. The most commonly seen color cast is when you use color film inside under Edison style incandescent light bulbs, and the whole image will have a kind of orange color cast. If you photograph outside in shade or under cloud cover, your image will have a kind of bluish color cast. Under fluorescent light, which is ghastly light, your images will have a sort of yellowish green color cast. And in fact, most of you are probably not under fluorescent light right now. If we were in a classroom, it would be really obvious. The color cast that fluorescent light gives out is so ghastly that even our brains can't completely compensate for it. And everyone looks a little kind of sickly, kind of yellowish. But in general, our brains compensate for this. But the cameras don't, or at least film cameras don't automatically. Digital cameras do, depending on the settings that you use. And so it's Aaron, right? Aaron talked about different colors and being able to change them. And in programs such as Lightroom, you can do very easily. You can manipulate colors and get rid of color casts.
All right, I have a quick question.
1 second, I'll get to you. In the cameras, in digital cameras, you have something called the white balance settings, and you can change that setting to fit, in fact, you should, to fit the lighting situation in which you're photographing so that you don't get a color cast. Yes, Carolyn.
So you said the light can make it so film cameras will sometimes have like orangey or yellow tints.
Yes.
Is that why older photographs kind of changed that orangey color?
That's a good question. Not necessarily. So the color cast that I'm talking about is in the image when it's made, and when, if you have color prints, when it's printed out, because the film that was used was designed to be used under a certain lighting situation. So it was designed to respond to certain wavelengths, which we'll talk about in a few minutes. And when the wavelengths are different, the film is not designed to compensate for that. So in the past, you had to use a filter in order to compensate for that. I think what you're talking about is aging photographs, and with most photographs, and if you look at other things that like have been bleached by the sun, for example, the reds tend to go first, and they get kind of washed out and they look yellowish, sometimes a little bluish, and so many older photographs, especially, I shouldn't say especially, many older photographs age and they fade in certain ways. So the colors just kind of leave. And so they tend to look kind of, some of them actually look kind of greenish, orange. Others tend to look more yellow, blue, you know, but yeah, they do fade. They don't, not all of them age that well, especially if they've been shown, you know, if they've been on display for years, they get washed out. Okay. Any other questions? Okay. Oh yeah, go ahead, Gus.
Yeah, the white balance on a digital, then when you're setting white balance to auto, what is it actually trying to calibrate against?
So when the white balance is set to auto, it kind of looks at the situation and does its best to see what it is and compensate for it.
So it does it on a picture basis?
I'm sorry?
It does it on a picture-by-picture basis?
Yes, exactly. Yeah. Let me just get to my notes here. So again, films. So if you've ever looked at a roll of color film, it says on it, on the actual cassette and on the cardboard box it comes in, it says daylight, and it will also say 5,000, and then with the letter K after it. And that's telling you what the color temperature is that the film is balanced to. And that's what I want to talk about for right now. So let me just share the screen here. Okay, so these are the notes that are in the module, you know, the white balance, color temperature white balance module. So these are the notes that you would be seeing, that I would be writing, as with the others, were we actually in class. Excuse me. So I would write out Roy G. Biv and ask you what that was, but it's already here. So ROYGBIV are the letters for the colors of the rainbow. So red, orange, yellow, green, blue, indigo, and violet. And so when you see a rainbow anywhere, if it's raining or if you're spraying your hose and the sun hits it the right way, these are the colors that you see. And these are the wavelengths that we are capable of seeing out of the entire, what's called the electromagnetic spectrum, or the spectrum of light. So the sun puts out light across many, 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 many wavelengths, a very minuscule portion of which we can see. And so that's what these are, these colors. And it's called the visible portion of the spectrum of light. So we can see this part. There are other parts of the spectrum put out by the sun that we cannot see. And we've heard of them. I know we've heard of all of them, but we don't necessarily know that's what they are. So the wavelengths go from longer to shorter, or shorter to longer. The wavelengths that make up light are so small that we can't see them. So a wavelength is the distance, if you see up here, from peak to peak, or from the lower part, which is called a trough. And again, they can be minuscule or enormous. If you've been in an earthquake, many of those wavelengths are many, many feet in length. I was in Capitola, about to get onto Highway 1 during the 1989 Loma Prieta earthquake, and I could see the overpass going like that in front of me. And what I was seeing were the actual waves generated by the earthquake. It was a little alarming to see them coming right at one, but so wavelengths can be enormous or minuscule, and these are minuscule, but some are longer than others. So the red that we see, the red colors, have a longer wavelength than blue and violet. Beyond red, even longer than the red color wavelengths, all the way out, are television and radio waves. Microwaves, which we of course use for heating up food. Infrared, maybe some of you have heard of infrared, far and near infrared. So certain films, that is photographic films, are sensitive to infrared, and you can make infrared images. We cannot see infrared wavelengths, but the film is sensitive to infrared. If you've seen movies where policemen or some people have these high-powered rifles that have special sights on them, and they can see the outlines of people in buildings, what they're seeing are the heat signatures of those people and in infrared. And the sights that they have are sensitive to infrared, and so can pick that up. So that actually is real technology. But again, infrared is, it can be sensed by certain kinds of film and certain technologies, but we cannot see it because the cells that sense color in our eyes can't see beyond the red portion or the violet portion of the spectrum. Question, yes.
Does red have a longer wavelength than violet?
Yes, it does. Oops. Shit, sorry. Forgot to turn my ringer off. Sorry. Decline. Sorry about that. I always do that. At least for a couple of classes, I always ask people to turn their devices off, and then I have neglected to turn my own off.
Okay.
We turned it into a dance party, so it's fine.
Yeah, every time I hear that ringtone, I just start dancing. I don't know why.
Yes, so the red wavelengths are longer than the blue, the violet. Mm-hmm.
Okay. The same with, it just goes, left side is longer than the right side?
You know, you can flip it around.
Okay.
Some diagrams show it this way, and I've seen others that show it in the reverse with violet first and then getting longer.
ER.
It doesn't actually matter, you know, which way you look at it. You know, they get longer, they go from longer to shorter or shorter to longer.
Got it. Thank you.
So after infrared, we go into the visible portion of the spectrum, which is what we see. And the different colors actually focus at slightly different points in space. They're so close that it doesn't, for us, for our purposes, for seeing, it doesn't make a difference. There are scientific lenses that actually focus on specific colors to get things that are even sharper. So I remember I worked in a photo store for some years, and we sold some scientific lenses to be used in the darkroom, actually, to focus only on blue, for example. We don't really have to worry about that. If you've ever shot infrared film, this lens is so cheap, it doesn't have it. But many older cameras, if you see their lenses, there's a red dot that's over just a little bit from the center hatch mark for focusing, and that was used for infrared because infrared wavelengths focus at a different point in space that we can't see because we can't see the infrared. So when you shoot infrared, you have to move the focusing ring over a little bit and take it on faith, or the faith of the, on the lens, that where you're moving it to, that red dot, is that point in space that infrared focuses at.
What would be the point of shooting in infrared?
A good question. Infrared images just look different. They look weird. In black and white, certain things that reflect a lot of infrared, for example, human skin, foliage, grass and palm trees, they reflect, if they reflect a lot of infrared, it looks as if they're glowing. So it gives us very otherworldly, kind of weird effect. In color, you get some very strange color reversals. You get colors, it's like if you did a paint by numbers kit and replaced the numbers with different colors, it just looks not right. But it appeals to some people, and they like the effect. So some people really like to photograph in infrared. It's difficult to find infrared film these days because a lot of film manufacturers don't make any film anymore. But digital cameras actually are sensitive to the infrared portion of the spectrum, and filters are placed over, or filters placed over the digital sensors so that it doesn't record infrared. But those people who like to shoot in infrared have that filter removed so that they can shoot in infrared digitally. So I'll just bring up a couple of images so that you can see them. Just one moment. So if you can see any of these, did these come up? No?
Yeah.
Oh, okay, good. It's like, I have to ask every time. So you can see the color ones. So the greens are replaced with a kind of intense, kind of cherry color.
Reds.
In black and white, you can see that certain, the foliage, again, the leaves just glow intensely. Airplane, the contrails that planes make in the sky, those glow. Those reflect a lot of infrared. These are all landscape. Human skin can look really weird, especially in black and white infrared. And I'm not seeing it here, but kind of alien-like, depending on your sci-fi experiences. One weird thing about humans, and infrared is that our eyes do not reflect infrared, so they look like these black holes. I'll try and find some images, but anyway, some people really love to use infrared. One thing I will say about infrared and like any kind of effect, using special effects filters, extreme lenses, you can get the most amazing effect. But don't forget that it's an effect and that you still want to make the best image that you can in terms of composition. And the effect doesn't take the place, or shouldn't take the place, of your composition and of what you're trying to say photographically. And hopefully the effect that you are using or adopting adds to that, if you know what I mean. Right. Okay, so back to the spectrum of light. So we go through the visible spectrum and to violet, and then beyond violet is ultraviolet. I'm sure we've all heard of ultraviolet radiation, how damaging it is to us, to our skin, our eyes, plants, which is true, it is. And the general rule is the shorter the wavelength and the smaller the particle. So light has the properties of wave and particle. In photography, we deal with wave phenomena, but it also has the aspects of particles. And the smaller the particles, the more damaging they are to us. And so beyond ultraviolet, as you get to the shorter wavelengths, X-rays. So we've certainly heard of X-rays used diagnostically, also for certain, usually cancer treatments, and beyond X-rays, gamma rays. And I am obviously leaving out many different types of radiation. Gamma rays are produced by radioactive isotopes. So are alpha and beta waves and particles. Anyway, all of these produced by the sun, and the small portion of them, called the visible portion of the spectrum of light, we can see. So these are wavelengths, but we don't refer to them as wavelengths generally in common parlance or speech. We refer to them as colors. Scientifically, they are referred to by their color temperature. So color temperature doesn't refer specifically to temperature as we think of it in terms of hot and cold per se. It's another way of describing the colors in terms of their wavelengths. The color temperature scale that's used is called the Kelvin scale. So those of you who have studied science, in particular chemistry and physics, have probably dealt with the Kelvin scale. It has a relationship with or to the centigrade or Celsius scale. And so 0 degrees Kelvin, which is a theoretical point, when all molecular motion ceases. It's so cold that nothing moves. No one knows if that point can be reached, but that temperature in centigrade is minus 273 degrees centigrade. So that's how they relate. The Kelvin scale looks at colors in the opposite sort of, or describes colors in the opposite way of how we tend to think of them. So an image that has reds and oranges, golds in it is described in artistic terms or just in general by humans as a warm image. It has a lot of warmth. An image that has blues and violets and some greens is described as cool or cold. And the Kelvin scale is the opposite. So the higher the temperature in Kelvin, the more blue the light, and the lower the temperature, the more red. So again, that's the opposite of how we tend to think of and describe colors. So I'm going to give you this scale here. It's here for you in the notes and also in the reading that I put up. But the highest temperatures that we tend to deal with in photography are up here around 11,000 or 10,000 degrees Kelvin. And that's very, very blue light. So if you're in deep shade in a forest, the time just before sunrise or just after sunset. So if you happen to be up early in the morning, which I usually am not, but if you happen to be, you know that the light is, the light before the sun rises is it's a deep bluish purple. But immediately the sun comes above the horizon, all of a sudden it's this intense reddish gold. But the time just before the sun comes above the horizon has a very, very high color temperature, 11,000, 12,000 Kelvin. And that happens just after sunset as well. So if you're out watching the sunset, you know, it gets more and more gold and red. And then immediately the sun dips below the horizon, it turns this bluish violet. So that's that blue, that intensely dark blue color. Below that, over here, is 8,000 Kelvin, and that's shade. So if you're outside in the shade of a building, for example, where no direct sunlight hits it, that light also is very bluish. It's not as blue as above, you know, at 11,000 or 10,000 Kelvin, but it's still pretty bluish. 7,000 Kelvin is outside on a cloudy day, but maybe higher cloud cover, where it's still pretty bright, but cloudy. And then below that, at 5,500 Kelvin, that is daylight. So outside, depending on where, you know, the time of year and where on the earth you happen to be, but for most of us, between 10 a.m. and 2 p.m. is daylight, and that color temperature is 5,500 Kelvin. Our flashes, the flashes that are built into our cameras, excuse me, those also are balanced to daylight at 5,500 Kelvin. So if you use a flash indoors, which is generally where we use them, everything that is illuminated by the flash will be balanced to daylight, as if you were shooting outside under daylight. Anything that's not illuminated by the flash will have whatever color is cast by the ambient light, by whatever lighting situation you're photographing in. Below that is 3,200 Kelvin, and that's called tungsten light. Into that category also falls incandescent light. So those are the Edison style light bulbs that are being phased out, you know. Also, if for any of you who have worked in photo studios, the bulbs that are used in photo floods are generally balanced to tungsten light. And this is the kind of light that you get an orange color cast in if you're shooting with daylight balanced film, or for those of you who have messed around with your white balance, which we'll talk about, the white balance, the daylight setting. If you have it set to daylight and you photograph inside under tungsten or incandescent light, you'll get an orange color cast. In the past, we had these bulbs that had different wattages. And so a 100-watt bulb, which is a pretty bright bulb, has a color temperature that's a little higher than a 60-watt bulb at 2700. And again, as the color temperature decreases, the light gets more and more orange and then red. Modern bulbs, the newer bulbs, are now described in lumens, and that is the actual output of light. But it will also give you the color temperature. So if it says cool, bright, that means that actually it has a higher color temperature, and it's probably up around 6,500 or 7,000 Kelvin, and it gives a bluish light. Daylight, or if it says bright white, will be at 5,500 or thereabouts. And then if it says warm light, or one like GE had an ad for their lower color temperature lights that, you know, kind of homey, but I can't remember the word. Those have a lower color temperature at around 2,900 or thereabouts. So that's what that means when you go to buy bulbs. That's what they're talking about. Down at 1900 Kelvin is candlelight. So you know that's very orangey red light. And the lowest color temperature that we can see is a deep red, around 900 to 1,000 Kelvin. So if you've ever seen pictures, or if you've ever been to a volcano of lava, just before it cools and goes black, that deep red color is down at that color temperature. So these color temperatures are another way of describing the wavelengths for these colors. And again, when we shoot film in these different situations, we'll get different color casts because the film has a set receptor. It's set at daylight. And again, our brains are not, hopefully. Digital cameras are, but you can change it. And so we can change something called the white balance. And this allows us to change the sensitivity, essentially, of the digital sensor as to what it still takes it all in, but what is important. So if you shoot in RAW, so remember we talked about different file types, and your cameras can record, excuse me, or can make images in the JPEG type of file, which is the most common image type of file, and also RAW. JPEGs are what are called lossy, and a certain amount of information is dumped in order to make the files smaller. With RAW files, no information is dumped. And so if you're shooting in RAW, it actually doesn't matter where you've set the white balance because no information is dumped. However, in JPEG, because information is dumped, it's more important that you set the white balance accordingly, to the proper setting for the light type under which you're photographing. And I'll get to that more in a moment. So, if you have your white balance, and I'll talk about that again in a moment, if your white balance is set to daylight, or if you're using daylight film, these are the color casts that you get under different lighting situations. So in daylight, obviously you don't get a color cast because that's what the film is designed to be used under. Under incandescent or tungsten light, you get an orange color cast. Under fluorescent light, you get a yellow-green color cast. Under cloud cover or shade, you get a bluish color cast. So in the past, we had to use filters to compensate for these color casts. So if you had color film, but you wanted to photograph inside under incandescent light, and you didn't want an orange color cast, you would use a blue filter. So blue neutralizes orange. And so if you use a blue filter under incandescent light, that orange color cast is neutralized. If you happen to have tungsten balanced film, which not that many people use, certainly not anymore, if you photograph outside under daylight with tungsten balanced film, you'll get a blue color cast. And so to compensate for that, you would use an orange filter because, again, orange and blue neutralize each other. So these are called color conversion filters, and they're like the big guns of the filter world. They're the intense filters that you use when you're photographing under the wrong lighting situation for the film that you have. You didn't use them usually just for kind of tweaking the colors. You use light balancing filters for tweaking. So, sorry, a question or somebody?
Yeah, if you use like incandescent, if you're in a setting where there's incandescent light and you use the incandescent light setting, does that neutralize the colors?
Yes, it does. So in effect, you're applying a color conversion filter. Okay, so I'll talk about that in more detail in a moment. Okay, yeah. So the light balancing filters are what were used for tweaking. So if you thought your image was just a little too bluish, you'd use a number 81 pale to medium amber to warm it up a bit. If you felt your image was a little too warm, a little too orangey, you'd use a number 82 blue filter to tone it down a bit, to get it a little bluer. Under fluorescent light, again, you get this kind of ghastly yellowish green cast where people look a little corpse-like. And some people like that effect. Most people don't, though, and it's not very flattering. So a magenta filter is used for that. And those are called FL for fluorescent, -D for daylight. So an FLD filter is a magenta, an intensely purplish, pinkish purple filter, and that neutralizes the yellow-green color cast that you get under fluorescent lights. Okay. So those are the filters that are used. Happily for us, in digital photography, we don't have to go out and buy filters because we're not using film. We have digital sensors. And so we can go into the white balance setting, and on most digital cameras, you can either go into the menu, or there should be a little button on the back of your camera that says WB for white balance. And when you hold it in, a little menu should come up that will allow you to change the white balance. So some cameras have it in words, others have little drawings or icons, some have both. So for auto, you'll have an A, and that means that the camera will do its best to figure out your lighting situation and compensate for it if need be. But you also have these other choices. So daylight, and you may have a sun, a little icon with the sun at 5500 Kelvin. Then incandescent, and some of your cameras may say tungsten instead of incandescent, and it will show a bulb. So around 3200 Kelvin. The icon is usually a light bulb. Fluorescent, and some of your cameras may have a couple of different fluorescent settings for more intense fluorescence and not quite as intense. And then it'll have this icon of a fluorescent bulb, which I have to tell you took me some years to figure out that's what it was. It looked more like a centipede to me, but anyway. Cloudy, a cloud. Shade, usually a building throwing a shadow or shade. Flash, so a lightning bolt for flash. And then finally custom, and it may just have the letter K for Kelvin. And in the custom setting, you can set a specific color temperature if you want to. Flash, in some ways, doesn't make sense, because the flash is set to daylight anyway, to 5500 Kelvin. So theoretically, it doesn't matter what white balance you've got set. Wherever the flash hits, it should be daylight. But when you put the white balance setting into the flash, the actual flash setting, and use the flash, you'll notice that there is a slight difference between them. Usually the flash setting has a little bit more orange in it. So when you change the white balance, you are in effect applying one of the filters that we just talked about. So if you're photographing under incandescent light or tungsten, and you set the white balance to that setting, you are in effect applying a number 80 blue filter to neutralize that orange color cast. When you set the setting to shade, which is a more intense blue, it's as if you are applying a number 85 orange filter to neutralize all of that blue color cast that you get in shade. If you're out under cloud cover, which isn't as intensely blue, and you want to compensate for that and set the white balance to cloudy, it's as if you're applying one of the light balancing filters, the number 81, number 81 amber filter, not as intense as orange, but to neutralize the bluish tint that you get under cloud cover. Under fluorescent, when you change the white balance to fluorescent, it's as if you are applying the FLD filter, the fluorescent, that magenta filter, to neutralize the yellow-green color cast that you get under that light. Excuse me. So, any questions on that? Anybody? So let me just bring up a few images to show you with respect to this. Let's see.
Oh, Sita, I
Yes.
remembered what I wanted to ask you.
Oh, good. Okay.
So you mentioned at the beginning of the class that you were recording the sessions.
Yes.
Where are they posted?
They're in the, and they're not all there, but they are in the modules under Zoom meetings, I think. It's called something to that effect at the bottom of the mod, at the end of the list of modules.
Okay.
So let me just get back here. So can you guys see this?
Yep.
Okay. So this shows this this in the reverse. So from ultraviolet to infrared, but it's the same information. And then they give you the measurements in nanometers also. So tiny, tiny, tiny little measurements. And again, the higher the color temperature, the more blue the light, the lower the color temperature, the more red or orange. So to get to the white balance menu, you go into your menu, or again, hit the WB button on the back of your camera. And you should see, not this, because whoever published this spelled fluorescent incorrectly. They left the C out. Very bad, but I wanted the icons to show you. And then here, incandescent, fluorescent, and so on. This camera, whichever it happens to be, has 4 different fluorescent settings, if you have need. Right. You may wonder why I'm showing you paintings, but I have a reason. This image, this painting was made by an American painter named John Singer Sargent. It was painted in, I think, the 1870s in Paris, and it's entitled Madame X. And it was not well received at the time for a couple of reasons. First, even in Paris, her dress was considered very risque, as if it was just going to pop off. But the second reason is that her skin tones have a lot of blue in them. So if you look closely, there's a lot of blue, even violet, in her skin tones, and people really didn't like that. Sargent didn't make that up, actually. This woman, whose name was not Madame X, but she was a social figure in Paris, actually put violet and blue in her powder that she put on. So she wanted this effect. But we humans tend to react on a subconscious level more negatively to those skin tones. And in general, we tend to react more positively to images, for example, that have more reds and golds in them rather than the cool tones. And it's not that we don't like blues and purples and greens, but on an emotional level, we respond more favorably to reds and oranges and golds. And it's not something that most of us really notice, again, on a conscious level. Here's a painting by the Spanish painter Pablo Picasso, and he, as you can see, did notice. And so this was made during his blue period. But you can see that he was really very aware of the color cast that you get when you don't have direct sunlight. So there is a tiny bit of direct sunlight coming in from this window, but everything else is blue. Not that there aren't other colors there, but they have a blue cast to them because they're in shadow. Or shade, I should say, or whichever. So he was much more tuned in to this, and to color temperatures, though he didn't necessarily describe them as such, than most of us are. Because when we're in shade, we don't necessarily notice that everything is now a little bluish, right? One thing I've noticed especially is in dappled light, where you have shadows and bright highlights, like under a tree where you have some light filtering in. We absolutely ignore that. But when we photograph in that, then we end up with these areas of dark shadow and bright highlight that we didn't even notice when we were photographing. This is a painting made by a painter named Thomas Kincaid, trademark painter of what is it, light, I think was his trademark. And some years ago, you'd see these his studios all over the place in malls and so on. And his paintings they weren't all the same, but they were all very similar. They all had the same kind of what's the word I want? They're all in the same kind of genre. So they're all outside. They're all done around twilight as the sun is setting. They're all little villages with these kind of gingerbread houses. There are always lots of chimneys, and they're all going. They all have smoke coming out. There's always a church, almost always a church, with a cross, a body of water, and every single window is illuminated. And you can see that they're all this kind of orangey gold light, which is, for us, incandescent light. And they are all designed to give you the same feeling of coming home in the evening, of the warmth and comfort and security of the home. And that is done by using these colors in the windows. Everyone had fluorescent bulbs in their windows with that kind of bluish, yellowy blue color cast, it would be almost repellent, It wouldn't be inviting. That's not what we associate with comfort and security. And probably from, hundreds of thousands of years, millions of years of using fire as not just for cooking, but for security, for protection. That's so ingrained in us that we still associate these colors with that, with warmth and security, with home. And so this painter uses that to the extreme, But again, it's not necessarily something that we pay that much attention to consciously. Except, I think, when you see a painting like this, where it is so obvious, every single window, it's like a PG&E dream. Every light in every single house turned on. And of course, there are fires going in every single one. So here's an image of these two men sitting somewhere in Italy, I think, with a cat. And it looks a little bluish, but we don't really, it's okay. Until we see the next image. And then we're like, oh, yeah, that's really blue, So, again, until we see it corrected, we may not even think that much about it. Now, this one is so extreme that I can't help thinking it was tweaked a bit. But the image on the left is supposedly made just with incandescent light, and I would say there must be a little fluorescent there too. So this kind of yellowy, kind of yellow-orange, kind of yellow-green. And And one way to tell, although this one's so obvious, you can't help but tell, look at the whites, or the areas that are supposed to be white in an image. And if they are off, then there's probably a color cast there. So this is so obvious that it looks as if he's wearing a yellow, kind of cream colored yellow shirt. But here on the right, you can see it's corrected for, and it's very, very obvious that it's been corrected for. And the whites are neutral, right? This is what happens if you're in daylight, and it's not a very good example, and you change the white balance when you don't need to. And I had a better example. This is better. So all the way to the right, the white balance is set to daylight, and that is essentially correct. Shade, so we're going from right to left. If you put the white balance to shade and you're photographing under daylight, you're going to get a really orangey image, because normally you'd set the white balance to shade when you're in shade, and the shade is very blue, or the shade gives you a very blue color cast, and so you'd use orange to correct for that. If you don't have all that blue, then the image just becomes orange. And the same for cloudy, but to a lesser degree. And some people, to a certain extent, this is how you want your image. You determine it. So you can make the image more orange than it actually was. That's up to you. But or more blue. But when you apply the cloudy white balance setting to daylight, it will be somewhat more orangey or golden than it would be at daylight. Flash theoretically should be the same as daylight. It's not quite. It has the tiniest bit more orange in it. So if you look at them side by side, and unfortunately, it's not in the exact same place, but if you look at the sand has a little bit more orange than it does under daylight. Fluorescent looks terrible. Fluorescent and tungsten both look really bad. So fluorescent turns kind of purplish magenta, because the filter that you use under fluorescent light to get rid of the yellow-green cast is magenta, is purple. And so if you don't have a yellow-green cast, it turns the image magenta. And tungsten, if you were actually photographing under tungsten or incandescent light, you would have a very intense orange image, color cast, and you use blue to compensate for that. If you don't have the orange, then the image turns blue. And again, these last two, fluorescent and tungsten, are pretty unacceptable. They just don't look right at all. Adding some orange to the image, I think the shade is very obviously too orange, but it's a tone you might get at the end of the day, when the sun is starting to set. So with the oranges, in some ways, it's a little bit more to your taste, but rarely will you use tungsten or fluorescent in this way, because they're so, for our way of seeing things, so wrong, if that makes sense.
If you wanted to make trees all pink and in that images that you showed us, what setting would you use?
So the ones I showed you were done with infrared.
Infrared?
And so in order to mimic that, you could use a red filter,
Okay.
but it's hard to do, because with infrared, only the parts that turn those colors are the things that reflect infrared radiation. If you use a red filter, everything will have a red color cast.
Would it just be better to do that in editing?
Yes.
I see.
so. Yeah, you can do replace color or something of that sort, and it would be much, much easier. Yeah. Or
Okay.
if you really want to shoot infrared, you can have that filter removed from your camera.
I saw there was like conversion kits or something.
Mm-hmm.
Camera.
Right.
I thought that
Yeah.
was pretty cool.
So yeah, you can do that. But then you probably just want to dedicate that camera for infrared.
Yeah.
Are the filters actual filters, or is it a post-processing that goes on in the computer?
That's actually a filter. So there's a physical filter placed over the sensor, the CCD or the CMOS, that blocks out infrared. But you can have it removed. But it's a physical filter.
Now, the case, just to clarify, so the picture that you're showing right now, if I chose fluorescent in a fluorescent light environment, are they trying to simulate daylight?
Yes. So
Okay.
So if you use the fluorescent white balance setting under fluorescent light, you should be able to make an image that looks as if it was shot under daylight with no color cast. Okay, so the
So
fluorescent,
that's true for all of
that's correct. So what I'm showing you here is when you use the white balance settings under daylight, which they're not designed to be used under, except for the daylight setting.
But if you use them in their appropriate
That's,
setting,
then they should correct.
daylight.
Then they should correct for them. Yeah.
Okay.
So here is the, you can see I lifted this image from Schneider Optics, and they want you to know that. But the image on the left was made under incandescent light with a daylight setting or daylight film. And then the image on the right was made with the filter, or you could say with the incandescent white balance setting. And it's corrected for, and so the whites are neutral, whereas the entire image here has an orange color cast, right?
You know, what's interesting on that, if you look at that picture, I mean, I can see aspects where sometimes you want to do both.
It's true. You may not want it to be absolutely neutral,
Right.
and that's up to you. It's your image. Maybe
Yeah.
there are some photographers who shoot with the orange color cast.
Yeah, to me, the one on the left looks warmer.
It does, absolutely. Mm-hmm.
Okay.
So, as you go through life, you don't have to compensate for it all. There are some that you might want to, but it's up to you. And especially if you're shooting in RAW,
Right.
no information is actually dumped. So it actually doesn't matter what white balance you have set if you're shooting in RAW. But if you're shooting in JPEG,
Right.
it is important because that information is dumped. Right. And then you
Right.
actually have to correct for it after the fact. And especially if you're working in Photoshop or I should say not working in Lightroom, where the information is actually changed when you work on an image. Every time you work on it, a certain amount of information, I should say the image degrades in some ways when you work on JPEGs.
Mm-hmm.
So you want to go in with the best image possible before you work on it, especially with a JPEG. I mean, you kind of want to do that anyway, I hope, but it's important with JPEGs because you're working with less information anyway. Okay. So
Okay.
just bring up one more thing here. Well, it's not here. Just one moment. Just out of curiosity, can you see what I'm doing here? Opening things up?
Oh,
No? So funny. Well, this thing's so slow. I'm so sorry. Hmm. Okay, I know this one takes a little while. All right. So can you guys see these?
Yeah.
Yes.
Okay, good. So on the left, the white balance is set to daylight, and it was made on a kind of bright, cloudy day. And on the right, the image was made with the white balance set to cloudy, so it compensates for that slightly bluish tone that the image on the left has. So can you guys see that there? Again, on the left, the image shot with the white balance set to daylight. And then on the left, did I say this correct? On the left, the white balance set to daylight. On the right, the white balance is set to incandescent. So you kind of have to know that the image is not entirely orange. But when you see it shot with the white balance at incandescent, you can see it's greatly toned down. And that there are, in fact, some other tones in there. So this is under fluorescent light, and you can see this kind of ghastly yellow, yellowish green or greenish yellow tone. And you see all the whites are that tone. And then when corrected for with the fluorescent white balance, which is with a regular, a real physical filter, magenta, it neutralizes that yellow green. Still not the most uplifting of images there, but there you have it. And then in shade, so the image on the left is, it has a lot of blue in it if you look at it in that way. And then with the white balance set to shade, it really brings out the oranges, maybe a little bit too much, actually. And so I find the shade setting to be pretty intense, and I don't use it very often. But if your image is, if you're photographing when there's a really intense blue tone, then the shade will really help, the shade white balance. This is a little more subtle. And I don't know that it's the greatest example, but under daylight, of course, probably going to shoot with the white balance set to daylight. But you can also set it to the auto setting, and there will be subtle differences depending on what the camera thinks the image should look like. So theoretically, under daylight, these should look the same, but they rarely do. Okay. And under flash, this also is a difficult situation in a way, because there's so much orange and reddish stuff. Theoretically, when you use the flash, it shouldn't matter if you have the white balance set to daylight or to flash. They should be the same because flashes are balanced at 5500 Kelvin, which is daylight. But you will find that the flash white balance setting will give you an image that has a little bit more warmth, a little bit more orange. And so even in this image that has so much orange on the left, the whites are true pretty much. They're pretty much without color cast. But the whites on the right with the flash white balance setting do have a little bit of orange in them. Okay, so those are examples of what happens when you change the white balance. Okay. Any questions? And we'll go over it again. So your next assignment after motion is white balance.
Oh, actually, when is motion due?
We'll have it due at the end of the week or by Sunday so that we can look at them. I'll have them graded and look at them on Monday.
Okay, I gotta start.
Oh yeah, right.
But you're saying Sunday, 11:59 p.m. or what?
Yes.
Okay.
I mean, hopefully you'll get them in before that, so I have a little time
For motion?
all night grading your motion images. Yeah, for motion.
For motion. Oh, okay. And what about white balance?
That's great. So I haven't assigned the white balance yet, but the following Friday, I hope. And so I think, just a moment, I think that I have, no, I don't have the white balance up, but I'll get it up today in the, at the bottom of the course summary and under assignments. So with the white balance, I'll just explain briefly what the assignment is. I want you to find these different lighting situations. Daylight, obviously, shade. You may or may not be able to find cloud cover these days. If not, don't worry about that one. Incandescent light, that's inside under, incandescent or Edison style light bulbs. Fluorescent light, so inside under fluorescent light, stores. Now that we're opening up again, right? Stores have fluorescent light. Many homes have fluorescent light because, those weird, tube, circular tubes or spiral-like tube.
What about LEDs?
That's a good question. The LEDs are balanced to different color temperatures. And so you'll have to experiment. It may say on the bulb, may give the color temperature, but if not, just photograph it with the daylight setting. And if you see a color cast, the color cast will tell you what the color temperature is. So if under daylight with an LED bulb, with your white balance set to daylight, if your LED bulb gives you an orange color cast, then it's got a lower color temperature and it's as if it's an incandescent bulb. If it's giving you a kind of yellow-green color cast, then it is, in essence, a fluorescent that, has the color balance of a fluorescent bulb. Okay.
I think I may be able to change what settings I use because I have an LED lamp that changes.
Oh, that's cool. Yeah, I'd love to see what you get there.
So are you changing the intensity of the LED light or are you changing the actual color of the LED light?
I'm actually not too sure, but I can change the intensity as well.
Yeah.
Along with the color.
but you did it before you changed the intensity. It looked like you were changing the color temperature.
Yeah, it was the temperature. So this is like a incandescent,
RGB.
right? Or fluorescent. This is like the fluorescent, and this is like the incandescent where it's like really warm.
Yeah. Are those RGB LED?
No, it's not RGB. It just goes through those three settings.
Oh, I see. Huh.
It's a little ring lamp like this,
I got you.
and yeah, it's pretty cool.
One more variable we can play with.
So sorry, let me. So, can you guys see this?
Yes.
Okay, so this will be the next assignment. So I want you to find these different lighting situations, and I want you to make 2 images for each setting, for each situation. Ignore the first one for right now. So incandescent or tungsten, inside. So with incandescent and fluorescent, you'll be inside, finding this kind of light. And so don't photograph right next to a window where you have daylight coming in also. So I want you to make 1 image with the white balance set to daylight, and the second image with the white balance set to the correct setting for whatever lighting situation in which you're photographing. So for incandescent or tungsten, you'll make 1 image with the white balance set to daylight, and the second image of the same thing with the white balance set to incandescent. So you should see that hopefully that the one with the white balance set to incandescent is corrected for, is neutral. And then the same for fluorescent. You'll find a fluorescent a situation in which fluorescent light is being used. Make 1 image with the white balance set to daylight, and the second with the white balance set to fluorescent, right? And that's true for these others as well. So cloudy and shade and daylight will be outside. You need to find those situations. If you don't find cloudy, if you're not out at the coast, make another shade image. Will be fine. Okay. I don't want you to use the auto setting with one exception. Under daylight, you make daylight, but then instead of making another daylight image, use the auto setting so you can see the difference under daylight. So daylight being outside on a bright sunny day, okay? Not at dawn, not at dusk, but like in the middle of the day. With the flash part of the assignment, I want you to photograph inside as well. Turn your flash on. And then for 1 image, you'll use the daylight white balance setting, and for the second, you'll use the flash white balance setting. But keep... What's that?
No, I was gonna say that my camera doesn't have a flash.
Okay.
So I'm not sure what to do.
Does it allow you to change the white balance settings?
It does, yeah.
Well, in that case, don't use a flash and do daylight and
Okay.
and flash. Yeah, interesting.
If you use your phone flash, wait, you would have to sync it, huh? Never mind.
It would be hard. You can do it. It's harder to do that, to sync it, But
So
give it a try.
what's the difference between a flash and just a consistent light source?
A flash pops off. It's a burst of light.
Uh-huh.
And photo flashes are balanced to daylight. So the output is as if you were photographing outside under daylight. It's set to 5,500 Kelvin, whereas other light sources are set to different.
So your phone flash should be set to 5,500?
It should be, yes.
Does that mean if you just leave it on and take a picture with the light shining, that'll count as a flash?
It should. actually. Yeah, give it a try.
Hmm.
Give that a try.
Okay.
Baharak?
For number 3 and number 2, you said we have to go to the stores because of fluorescent light.
Not necessarily, but for fluorescent light, almost all
Mhm.
stores use fluorescent light, and so it's easy. Or you can assume that the light in a store is probably fluorescent. In your home, some people use fluorescent lights at home, other people do not. So you have to find out what type of light it is by looking at the bulb. Many bulbs will actually tell you what the color temperature is, but you have to figure that out yourself.
So we have to take a picture on fluorescent or not if we don't have the.
Yeah, you have to find it. Okay.
Okay. Thank you.
I do realize that since we are still sheltering in place, you may not have as many options. So I understand that. I think you probably will be able to find fluorescent light without endangering yourself. But if you cannot, let me know. Okay?
Oftentimes, you might be able to find it in the kitchen.
Very true.
Yeah, or like the supermarket even.
Yeah.
Or if your apartment building has like a laundry room.
True. Yes.
So, what kind of photo are you looking for? Just one of the environment, or?
Yeah. I mean, I hope that you won't just point it down at your, at
At your foot?
well, your foot is interesting. I hope you'll find something of interest, and think about it a bit. But I also understand that these may not be your ideal photo ops, so to speak.
Right.
Would you be able to, before class ends, would you be able to show some of our classmates' photos and just kind of go through your process?
Yes, let me do.
And
And I'm sorry, yeah, we're running out of time, unfortunately. So
Excited to.
We move on to the picture. One question.
what's that? Sorry, I missed.
Before you move on to the pictures, I went in and looked at the modules for the videos.
Yeah.
I don't see them.
Really? Okay, I'll check again.
I see JPEGs and I see other stuff, but I don't see video.
All right.
Here, let me check right now
I'll
too.
check that again.
I have one quick question on the flash requirement.
Yes.
What was that?
I
Yeah.
have one quick question on the flash requirement.
Yeah.
Did you want us to do each white balance setting on the flash requirement or just one to show the comparison?
I'm sorry. Would you say that again? That got totally garbled.
I know, I'm sorry, I'm outside. Do you want us to do the flash settings on each white balance setting, or do you want us to do just one to show the comparison?
Just one set. One with the white balance set to daylight and one with it set to flash, using the flash inside.
Okay, great, thank you.
2 images.
Okay, thanks.
Okay. All right. So let me see here. All right. Let me see who's here. Oops, sorry. Wow, hang on, there are a lot here. Okay, let me open these up. So these are, Olivia, are you here?
Yeah.
Okay, these are Olivia's. Can you guys see this?
Mm-hmm.
Yes.
So they're not labeled as to what has changed. Let's see. Hmm.
Properties.
Hmm. That's not helpful. Well, it looks as if they kind of changed as they were maybe imported somehow. So I'm not seeing any information, and I don't know why. But in this image, we're closer in, either because of the focal length or distance. And you can see the background is, in this image, the photographer is backed up either with the focal length or in distance. And Olivia, was this for distance or focal length?
Distance.
Distance. So you actually moved back by maybe a couple of feet?
Yeah.
Okay. And so you can see that the depth of field, that is the amount of space in focus, is much greater in this image as you move back than when you come in really close. You see the background is totally out of focus. So these, I would guess, then are for depth, using, changing the focal length of the lens. And in closer, this area is in focus, but you can see the background back up in the upper right, and then through the fence is out of focus. And as you back up, those areas are actually in focus. Changing
I just have to say, I really like that one.
this one.
Ooh.
Nice.
Yeah, beautiful. Now these two, I'm not actually
So pretty.
a difference. Yeah, beautiful flower, hollyhock maybe.
Look at the pollen. You just see the pollen on one of the petals.
Here, yeah. But actually, to me, the depth of field looks pretty shallow in both. So let's, oops. All right, let me find another set here. Okay. Is Allison here? Perhaps not. Okay, here we go. Let me just share screen. Okay. So I don't know if you can see the info thing here. Can you see me? No?
Yes.
Yeah, we can see it.
Oh, okay, good. So in this image, the f-stop was at 3.5, so wide open. And the depth of field is shallow. The background is out of focus. And, oops, sorry. In this image, the f-stop was f22, so stopped way down to small aperture. And you can see that the background is in focus. So, sorry, that's not what I wanted to do. So, shallow depth of field with a large aperture, great depth of field with a small aperture. Nothing else has changed. So the distance stayed the same and the focal length stayed the same. In this case, let's see what changes. The distance from the subject has changed. So this is coming in close with an f-stop of 5.6. And then backing up physically, so the focal length stayed the same, the f-stop stayed the same, but you can see that the depth of field has increased much more. The background is much more in focus. And then here the focal length of the lens is 18 millimeters, so wide angle, and the aperture is at f5.6, and except for the extreme foreground, which will often fall out of focus, the depth of field is great. So from the point of focus, this flower back, all the way back out here, everything's in focus. Here the focal length has changed to 55 millimeters, which is now it's gone from wide angle to normal. The f-stop is the same. Presumably the distance is the same. You can see that the depth of field has decreased a lot. It's much shallower. So the point of focus is still in focus, but now the background is out of focus because the focal length.
Quick question.
Yeah.
So I had so for the set for focal length, I had my fixed lens on there.
Okay.
I wasn't sure if you can change the focal length on there or you can just change the focal distance, right?
Right. So only the focal, you can only change the focal length on yours by putting a different lens on.
Okay.
You have a different
Change the
lens,
focal distance.
but if you, let me, write me a note or something just to remind me that you.
Oh no, I actually switched back to my kit lens.
You what?
So I was able to switch. I switched back to my zoom lens.
Oh, okay, cool. All right.
That way I was able to fulfill that.
That's great. That's fine. Yeah. So you know what? Let's go over these and your next assignment next time, and we'll spend the whole time doing that for those of you who are here. And in the meantime, your grades and comments will be loaded onto Canvas for this assignment, and eventually for the next one. Okay.
All right.
Any
Thank you so much.
questions, comments before? Yeah, Baharak.
Excuse me, where we can find tungsten lights?
So tungsten and incandescent are they're considered to be the same thing. And those are, the I don't know why I'm looking around. I know I don't have a light bulb here. But the traditional light bulbs, the round ones with the stuff in, the traditional light bulbs.
Yeah.
So those are incandescent or tungsten.
These kind of warmer colors, right?
Yeah.
Okay.
That's right.
Okay, thank you.
All right. Anyone else? Oh, yeah, go ahead.
No, the due date for this assignment is on Friday, you said? This Friday?
No, the following.
Oh, the following.
Yeah.
Okay, thank you.
All right.
So the assignment for this week is actually due on Sunday, and that's the motion study.
The motion, yeah. And I hope that, of course, that you'll get started on white balance, but yeah, that's not due till the next week. Okay.
Okay.
Will you be providing examples for the motion one?
Yes.
Just so we have
That's what I had. But I still need to get the panning ones up, I think.
Okay. Yeah, I need some inspiration for the motion ones.
All right. Here's my request that you don't, I know the guys don't like this, but
no cars.
No cars, at least for the stop motion for Frozen, because they just look like stopped cars.
Stopped cars with
parked cars. So if you're going to do that, my challenge to you is you better make it interesting in some way. Okay. Experiment with different moving.
Someone's going to start wilding now on a car.
Recruit your friends and family to jump up in the air or whatever, you know.
Birds are pretty good for motion studies.
Yeah, birds, animals work wonderfully. You can't always get them to do what you want them to do, but absolutely. Yeah. Okay.
Sunday, 11:59.
And
Or
hopefully
earlier,
before
if
that.
Earlier,
possible.
All right. Okay,
Okay.
well, I hope you guys have a wonderful week and weekend. Shoot, photograph, stay safe, stay healthy.
Well, did you get a chance to peek on the recording?
Did I what?
You get a chance to peek at the modules for the
Yeah, I'll
recording?
do that when we're done. Okay. I'll check.
Okay, yeah, you can send an email out to that effect. That'd be great.
Yeah.
For the
Absolutely.
And
Okay.
have the recording for the last.
Mrs. Sita?
Yeah, I will check on that because I thought they were there. Okay.
Okay, thank you.
Yeah.
Mrs. Sita?
Yes.
Oh, I just wanted to ask something once everybody's gone.
Okay.
All right. Well,
One-on-one time.
go away.
Bye.
I'll stay on. Okay.
How do we get out? Yeah.
Should be able to end.
Bye-bye. Thank you.
Bye. Take care.
Mr.
I ask
Chair, if
something?
you're there, I have one last question.
Yes.
On mine that I turned in, I went in Photoshop and I made them all as to one file instead of uploading different files, kind of like a content sheet, only bigger. Is that okay?
That should be okay. I'm trying to see where it is. What did you pick?
So far, I've uploaded the motion on both classes, and I think I uploaded depth of field on one of the classes.
Okay, I'll see what I can find. What's your last name?
Galbraith, G-A-L, like a girl, gal. So I just wanted to let you know that even though it's only one file, it has all of them in there.
I see. Yeah, so for the depth of field, you put them together. That's fine. Yeah.
Yes.
Yeah,
I
that's
thought that might be easier
It
to
is.
look through. I did it way before at the beginning of the quarter because I was trying to get ahead.
Good. All right.
So I didn't know the parameters at that time, so I did it all at that time.
It looks it looked good to me.
Okay.
Anyway.
Okay.
Okay.
Great. Thank you.
Okay, so we still have 3 other people here. 2.
I was just gonna ask one thing, if possible. Can you hear me? Sorry.
Yeah, I can hear you.
Oh, okay. Yeah. So you're probably gonna notice on my depth of field that I try to go a little bit artistic as well. Like, cause I saw that the examples you gave from the other students were usually from like household items or like flowers in the garden or things like that. But for example, like I went to a pier and I kind of changed a little bit. Is that a problem or is that okay?
No, it's great. I'm delighted to see other stuff.
Okay.
Last name, Lucas?
What? Sorry.
Your last name?
Oh, it's Gallo. G-A-L. Oh my God. Sorry about this.
No worries. And you submitted them to Canvas?
Yeah, so that was another thing that I was going to mention. So yeah, I submitted on Canvas, but since Canvas didn't let me put like an entire folder, I also sent to you on like a WeTransfer link, but it probably expired already because I saw that you didn't download it. So I don't know if you want me to send them again.
Would you send it again? That
I
would
will,
be great.
definitely.
Okay, thank you. Thanks.
All right. Thank you very much.
All right, take care.
Have a good one.
You too.
Bye-bye.
Well, okay.
Okay.
All right. Oh, so I have like a bunch of questions to ask. I feel like I'm sort of like kind of jumbled up. how did my last pictures turn out? I know that there's a few things I feel like I might have missed. Last thing is carpo. Um, and this past week, due to all these like circumstances that happened, I'm no longer in the Marine Corps, but I'm in the National Guard, and the National Guard got activated, and
Oh, wow.
we were running around and like so right
Yeah.
now I called my counselor and I had to like write a letter. It's just like if I ever fall behind, if I can have incomplete, so I can at least finish it over the summer and make it up, so I won't get a failing grade to
Right. Absolutely. There, that's
exposure mode. I mean, I'm still trying to figure out how to use my brother's camera though, because he like it's just auto exposure, but I was trying to figure out how to turn off everything and turn in manual mode. So that's what was kind of like getting mixed up. And
well, here you've done it. So you're an aperture. Can you see this? Your images here?
yes,
Yeah. Okay. So you're an aperture
yes,
priority. That's great. So the aperture is at 5.6 and at 22. Now in this set, if you're changing the aperture, I don't want you to move
okay,
or
all right,
change the focal length. So if you're going to change the aperture, don't change the focal length.
okay,
Okay. Let's see here. And the same. So either change the focal length or change the aperture. Okay.
but the auto exposure is fine though, right?
The auto exposure, well, it says auto exposure, but you're also in aperture priority. So that means that you change the aperture and the camera automatically sets the correct
Yes,
shutter speed. And that's fine. That's great.
okay,
So it looks as if in all of these you changed both the aperture and the focal length, except
yeah,
for these, but these are the same. That's
yeah. I was going from the lowest to the most extreme, like you said.
right. So take a look at the assignment again, and I want, as you did, I want 3 sets of images, but I only want you to change one thing in each. So if you change as in these images, the first 2,
Yes,
if you're going to change the aperture, which you did, then do not change the focal length. Stay in the same place and keep the focal length the same.
so just zoom in, get like the focus of that object, and then zoom out, and then that's it.
No, don't do that. Do not.
Okay.
So let's say you've made this image with the aperture at 5.6, right?
Yeah. Yes.
Then in the next image, don't move, keep the focal length the same, and change the aperture to f22. So the image will be the same
Oh,
in terms of composition, but the depth of field will change as you change the aperture.
okay.
Okay?
Okay. So you want me to redo it? I mean, if possible.
Yeah, I would redo these. Okay?
Sounds good.
And so for the second set, keep the aperture the same. Change the focal length of the lens. Now don't move and keep the aperture the same.
Got it.
And then in the third set, keep the aperture the same and the focal length the same, but come in close for one and then back up for the second.
Okay.
Okay?
Sounds good.
All right. Good.
Oh, we're still recording.
Oh, oops.
Yeah.
Shoot. Well, that was stupid. Hang on. I thought I had stopped.